one is, oh my gosh, solving an equation. What kind of equation is this? How do we solve it? Quadratic formula. Can we simplify this first or no? Or do you want to, we can use 18 as A, negative 24 as B, and C as 87. But if we can reduce it, that might make your life easier. Smaller numbers. Can it be reduced? By what? 3. It's an equation, so we can divide both sides by 3 and forget about it. 6x squared minus 8x plus 29. Go ahead now and do the quadratic formula with that. Okay. All right. Thank you. I'm going to pull out a couple tests and see.
Are we getting those back?
Eventually. If you get to a point and you feel like I don't know what I'm doing, raise your hand immediately, and I want to hear where the points of confusion are. That will just give me some feedback. Raise your hand if you get to a point where you got like this pit in your stomach, like, ugh. You're there? Where are you? Tell me what the last thing you wrote down was. $632. Why the pit in your stomach? You don't like big numbers, huh? And it's negative. Okay, Tori gets a pit because it's negative. You get a pit because it's such a big number. First of all, let's make sure that's right. Opposite of b is 8. Plus or minus the square root of b squared is 64 minus 4 times an a of 6 and a c of 29. All over 2 times the a of 6 does give you 12. So is that what you had, Maggie? And I can trust that that's right. So the discriminant is not only negative, but it's a big number. The negative part tells you that your answers are imaginary. So that's going to be 8 plus or minus I root 632. We can take out that I right away. Now, there were options for this. So how can we use these options? How can we use these options to help us realize how to break this down? They're all 158, correct? Yes? So we can kind of think about, well, how does 158 go into this number? This is, use your calculator, 158 times what? 4. Okay. So when now it's root 158, root 4. And I can actually take the square root of 4, what is that? Plus or minus 2i root 158 all over 12. Now, Brock, neither of these are options. I have to simplify this just one step further. How's that going to simplify one step further? I think this was another portion that caused issues. Jake O, what do you think? Right, all 3 of them is the key. We have a lot of people just reducing 2 over 12 or just reducing 8 over 12. Listen, guys, this is a binomial. This is like 8 plus 2x being divided by 2. You have to divide both terms of the binomial by 2. So you have to reduce both terms with the 12. So you have to look at all 3 and realize a 2 goes into all of them. So 4 is how you reduce the 8 by 2. The 2i just goes down to an I, root 158, and then all over this reduced by 2 is 6. But then again, look at those solutions, the options. Not only do they reduce everything, but they also split it up into two distinct terms instead of that binomial. So they have 4 over 6 plus or minus I over 6 root 158. And 4/6 then, when it's done totally separately, can go even further down to 2/3. Yes? So 2/3, it's a positive 2/3, so it's either A or D. Plus or minus, is it 6I or 1/6I? 1/6. I had I over 6. So that's 1/6. So this particular person, they have some work here, so I can get a little feedback as to what they did wrong. They didn't do anything wrong as far as not dividing a 3 out. Their life was just a little more difficult. And they did get everything down to, well, maybe it's hard to say, because maybe they just saw 24 over 36 and knew it was positive 2/3, so just kind of shot in the dark guessed and guessed wrong. So it's kind of hard to say on that one. This person also picked A, which was wrong. Hard for me to tell because their work isn't very well planned out. But they picked A as well. Come on, who's this one? This person picked the right one. Almost shocking though, because this right in and of itself, they might have guessed 2 and just happened to guess right. They had 2/3 plus or minus I. Their 6 is missing somehow. And they're over 12. So, anyway, again, is it the quadratic formula? No, I think it's your ability to work with very large numbers and some of your basics about, fractions breaking down. The quadratic formula is really an Algebra 1 topic. This is maybe a little more advanced because of the imaginary number, definitely. That makes it Algebra 2. And then just the size of the numbers, I would say. But anyway, that's that one. Number 2. This one, it's hard to read when I copied it, but this is the 6th root of x over the 3rd root of x. It says, which of these expressions are equivalent to, this is the expression, 1 divided by the 6th root of x. 6th root of x, okay? So, in each of these, we have radicals. So this is kind of bringing us to the combo of radicals and exponents. This is the 6th root of x up top. That's the same as x to what power? 1/6. Over the cubed root of x is the same as x to the 1/3 power. Exponent rules. When you're dividing common bases, what are you supposed to do with your exponents? Subtract 1/6 minus 1/3. I need a common denominator. 1/6 minus 2/6 is negative 1/6. Negative exponents, what does that do? Moves it to the denominator. And then 1/6 power is 1 over the 6th root of x. So that one works. I know a lot of people were able to tell me, well, these are definitely the same, right? So if this one works, here's an intermediate step of this one, so that one definitely works. And then this was just a negative exponent thing, 1 over x to the 1/6 power. That definitely works. It was all 3 of them. Okie doke. Trickster. Number 3, oh my gosh, I went through the Regents and I thought, the midterm, and I just did it with the January Regents that came out, and I went and circled all the ones that I think you should be able to get right on day 1 of this school year. Not because on day 1 of this school year you knew how to solve a radical equation, but on a multiple choice, guess and check, you should be able to get this one right. So a lot of you did what I am happy you did, and you went through and you actually solved this out, and you got 2 solutions. What you didn't do is check for extraneous. And so you picked this one, and one of those doesn't work. So you almost would have been better off if you didn't know how to do this one, right? course, I have to teach you how to solve this by hand in case it's an open response, which it has been in the past. But you have to check for extraneous roots. -8 doesn't work. Only 7 does. Or something like, yeah. That's it. Okay? Completely factor. We already talked about this one. This completely factored, I think people took out an M, and I think a lot of people chose C. I'll tell you exactly what percentage of you chose C, I think. I have to figure out which question this is. Number 10. Number 10. 53% of you got it right, but 30% of you chose 3. Chose this one, which means you factored the GCF, but you didn't factor completely. This is factorable further into m squared and m squared, 3 and 2, plus and minus. That'll make -6 and a positive 3m squared. And so the answer should have been this, which was option A. Completely. Okie doke. Okay. Our favorite kind of question. Iridium 192. The 192 means nothing. It's just the name of this chemical or isotope. Okay. It has a half-life of 73.83 days. So half-life means you lose half of the amount in that amount of time, right? So they gave you the formula. That was awfully nice of them because they did not need to do that, right? We could have written ourselves 100 parentheses 1 minus your rate of 50%, 0.5, to the T over P power, where P is 73.83 days. Which one of the following equations approximates the amount of this after T days? So, again, you could plug in any random number of days. Plug in 50 days. See how much of this is left. And then plug in 50 days, 50 days, 50 days, 50 days, and see which one matches. I think we need to do a better job problem solving around questions that we're not sure necessarily how to do the right way. But when it's multiple choice, use that to your advantage. Okay? You could have plugged in any number and then plugged that same number into all 4 options and see which one matches. Now, the way I taught this was to just plug in a 1. If you want to change it to a 1-day rate, plug in a 1. And you only have to worry about this there. The 100 is the same no matter what. So if you type in 0.5 to the 1 over 73.83 days, that's your new base, 0.990656, and you just changed it to a 1-day rate by doing that. So now it's T over 1, which is why you don't see a denominator of 1 in any of those because you don't need to write it. So which one is it? A. Okay? But do a better job problem solving and trying to guess and check a little bit more. Be a little more savvy. Writing an inverse. Oh, my dear word.
Hardest thing in the world.
Hardest. Not only that, it's a linear inverse. How is this one so bad? So switch the x's and the y's. So we get x equals -3/4 y plus 2. And then solve for y. So I could take a guess as to why so many people got this wrong, but do you guys know tell me what gives you that pit in your stomach? What makes this more confusing than other ones? Can somebody? I think it was the fraction too. You don't divide by a fraction, you multiply by the reciprocal. Yes? So instead of dividing by -3/4, we're going to multiply by -4/3. And then, depending on the options, it would be kind of the presentation of the options. You'll have to tell me if that is what caused mistakes. Inverse, here we go. You could leave it like this. You could distribute your -4/3 x plus 8/3. Because both denominators are 3, you could do -4x plus 8 all over 3. Any one of those. And here are our choices. This particular person chose D. but which one is right? B. And I think it was the fraction, to be honest with you. That's an Algebra 1 skill. Oh, Maran. I didn't know I signed up to teach Algebra 1 and Algebra 2 all in the same year. Don't worry. You'll get better. This is another exponent one. Rational exponents, kind of the relationship with radicals, right? Where does the denominator go if you're turning it into a radical? That's the root. It's the d root of 3b squared. Now the squared can go inside or outside. It does not really matter. So which one is correct? B, the d root of 3b squared. Perfect. Yep. What did you say? Oh, well, I don't know if it was that blurry on the test. I just copied this from the test, and sometimes when I make it bigger or smaller. System in 3 variables. Look at your A's, look at your B's, look at your C's. Which one's the easiest to eliminate the first 2 times? B. Add these together because opposite signs add. That'll give us 5A plus 3C equals -1. Subtract these two because same sign subtract. 4A minus -A is 5A. 4C minus -5C is 9C. And 19 minus 2 is 17. Now, the third elimination, what should we eliminate, A's or C's? A's. So 3C minus 9C, -6C, -1 minus 17, -18, C equals 3. Go backwards. 5A plus 27 equals 17. So 5A equals -10 and A equals -2. Go backwards to the beginning. If A is -2, then -2 is 2. Minus 5B minus 5 times our C of 3 is 15 equals 2. Add 15 over, subtract 2 over, -5B equals 15. B equals -3. So which one is not contained in the solution? -2 is, 2 is not. 3 is, -3 is. We always found this a little bit frustrating. A system of 3 variables is a lot of work for a 2-point multiple choice question. We don't agree with it, but that's the way they write it on the test. So unfortunately, that may be the way it shows up. If you divide by x plus 4 and the remainder is 0, what's the root? Root is -4. If the root is -4, which one of those is true? B. X minus 4 isn't a factor. If x plus 4 goes into it with no remainder, then x plus 4 is the factor. -4 is the root, so that's not it. Here is -4 being the root because this is the point -4, 0. Right? Remember the remainder theorem? Whatever the potential root is, which if you're testing a factor of x plus 4, your potential root is -4. Whatever your remainder is the y-coordinate that goes along with that. Definitely not no conclusion can be drawn. And g of 4 is not 0, because that would insinuate that 4 is the root, but we know that -4 is the root. And then lastly, undefined values. Okay? This is excluded values. What about a fraction makes it undefined? 0 in the denominator. So whatever would make this denominator 0 is what we're looking for. Okay? You don't know what makes this 0 until you factor it. So that's x plus 4, x minus 2. And so x equals -4 would make the denominator equal 0. And x equals 2 would make the denominator equal 0. So the function is undefined when x equals -4 or 2. Couldn't you just have guessed and checked here too? If this was better, this might have been like 60%. Did anybody have any other problems that they were just like that they remember they were kind of like weirded out by? What number? The P question.
Just like Lewis fractions.
Oh, this one?
Yeah.
Get a common denominator all the way across and drop them. That was actually not bad. So this one needed a P plus 3. I know the mistake that everyone made with this was right here. This gets a P minus 5 and a P minus 5. No, it was when you canceled, you didn't distribute the negative 2. Should have been negative 2P, which a lot of people had, should have been plus 10, and a lot of people kept it a minus 10. So it made it totally ugly. And then you probably got lost in the quadratic formula. The fact of the matter is, so this person did it. It was negative 2P plus 10. And it would have worked out really nicely. And it was very sad that it didn't for you because it should have. Okay? One thing someone did on this that I thought was fairly creative, it's not usually possible, but they noticed that these already had a common denominator, so they added the 2 over P plus 3 over. So they treated this side as P plus 2 over P plus 3 and 3P over P minus 5, and they just cross-multiplied. I thought that was very nice.
So
most rational equations are not going to work out nicely like that.
So bad.
To be truthful, if I was rewriting this question to be a little more Algebra 2 challenging, as it should be, because again, this is an Algebra 1 mistake. That is not an Algebra 2 mistake. The Algebra 2 skill is teaching you how to solve these things. Another Algebra 2 skill, and that I wish we could rewrite this to be, would be, what if I did this? Remember how we handled that? We gave this a negative 1. We multiplied by negative 1 over negative 1, which just switches this order, so it immediately becomes a P minus 5, and then your numerator is just negative P. So that's an Algebra 2 skill, is how to finagle that situation. But the mistake everybody made on this was not the Algebra 2 mistake, it was the Algebra 1 distributing mistake. Anything else? How was this one? Okay, so this one has 1, 2, 3 zeros. This one has 1, 2, 3, 4. Why did I count this one twice? Because it doubles. This one had 1, 2, 3. This one had 1, 2, 3, 4. So these are out. And then as x approaches negative infinity, that means as we move left, what does the y do? This one's going towards positive infinity, right? So that's out because it's supposed to go towards negative infinity. So this person got that one right. Did we read this and understand that was focus and directrix? Okay, because it doesn't use those words, and so I wasn't sure if you were going to be okay with that. So again, that, let me see, 70% of you got that right, so that's pretty good. System. Number 9 was an exponential one. And 72% of us got that right. That's great. We're doubling, so 1 plus 1 every 4 weeks. Currently 5 rabbits. And then you just plugged in 98 days, but you had to switch that to weeks so that we were in the same unit. Nice job. There's a system with a line, parabola. This is more exponent rules. I'm actually surprised that didn't show up as a bad one. 67%. It's not great. But this is just exponent rules. So dividing common bases, what do?